This video is going to cover zero force members. There's two specific cases that come up pretty often for zero force members. Case 1 is when you have two members at a joint with no external loads. Those members are zero force members. So for instance, let's look at joint C. At joint C, we have a corner with no external loads. So we have a force BC horizontal and a force CD vertical. What we can do at every joint is to sum the forces in the horizontal direction and vertical direction and set them equal to 0. In this case, when we sum the forces horizontally, the only force you have is force BC. So therefore, force BC is a zero force member. And if we sum the forces in the y direction and set it equal to 0, we have force CD and only force CD. So therefore, force CD is also a zero force. Now, that's pretty obvious when you have a 90-degree angle. So let's look at another case. If we look at joint A, joint A is just a joint. It has two members and no external loads. So we have force AB and we have force AE. Now maybe this is the angle theta. Who knows? Doesn't really matter. Because if we sum the forces in the y direction and set it equal to 0, you have only force AB. Yes, it'll be sine of theta, but that really doesn't change anything because he's the only one in that direction. So force AB is equal to 0. And if you sum the forces now in the x direction and set it equal to 0, yes, you have two forces. You have force AE and you have force AB times the cosine of theta. But since we know that AB is already 0, then you really just find that FAE is also 0. So it doesn't matter if they're at a right angle or not. If there are two members existing at a joint with no external loads, then those members are zero force members. Now we can take this a step further and analyze joint E. If we look at joint E, after we've analyzed the rest of our zero force members, then we're actually going to find one more zero force member. So at joint E, currently, we have the horizontal member and the vertical member, and we have a reaction, EY. He does count as an external load. So we have force BE, we had force AE, and we have force DE. Now we already found that AE was 0. So again, if we sum the forces in the x direction and set it equal to 0, we had AE, negative force AE, who was 0, and force DE. So now we've found that force DE is also equal to 0. So our truss is actually only two members, BE and BD. That's what this whole lovely truss boils down to. And that's just using case 1. For case 2, we have two collinear members at a joint and one non-collinear at the same joint. The non-collinear member is 0 force. Let's check it out. If we look at joint D, joint D is an angled member and another angled member coming out. So we have force CD, we have force DE, and we have force DF. Now how this works is by using a change of axes. We're going to say that this direction is our x prime direction, and this direction is our y prime direction. So if you sum the forces in the y prime direction and set it equal to 0, you only have force DF. So force DF is a 0 force member. Now, it doesn't just have to come off at that particular angle. In fact, once we have that FDF is a 0 force member, where else do we have two collinear members and one non-collinear member? Joint F, because technically we've erased DF. So if we go looking at joint F now we have two members, because technically this force DF is a 0 force member, so he really doesn't count. And we've got force CF, and we have force FG and force EF. And this one should make sense without having to change our axes at all, because if you sum the forces horizontally, you have 3 forces, but if you sum the forces vertically, FDF was gone, and it really doesn't matter what you take for any of these angles. Maybe that's beta and maybe that's alpha. But anyway, we have force DF times the sine of alpha, who again, we said force DF was 0. And we have force CF times the sine of beta, all of that equal to 0. So if DF is equal to 0, then that makes force CF equal to 0. So he's also a 0 force member. Now if you look at joint B, this is not the case. Because we have that external load at B, if you try to do the same trick we did at joint D, it doesn't work. And as far as case 1 goes, joint A doesn't work because you have the pin, and joint E doesn't work because you have the roller, and those count as external forces. If you look at joint G, you actually have 1, 2, 3, 4 members, so it's 2 collinear and 2 non-collinear, so that doesn't work. And C, whereas technically one of those is gone, we have 1, 2, 3 members, and none of those are matching up our cases. So those are the only 2 0 force members that we have in our second truss.